Okay, Assalamualaikum and very good morning. We are from Group 2 and my name is Hasif bin Roshidi together with my other partners, Muhammad Idris, Asraf Hanif and Muhammad Asraf. Today we're gonna do a present on Lab 3, VoIP Network. First of all, we are from UniKL BMI and our course is BET in Telecommunication. Okay, so in this network there are 4 router involved and together with some IP phone, some switch and also some PCs. Today, okay, without further ado, I pass to my partner Hussain to begin his part.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Raziff Abd Razak. My part is on router 1. Okay, first of all, on this lab, we must first step is do the physical connection. Okay, physical connection is for R1 is S001, S000 is connect to the R2, and S001 is connect to the R4, and FA00 is connect to the switch, and the switch connect to the first IP phone. First IP phone is here. The extension number is 1101, and second is connect to the second needs connect to the IP phone. Extension number is 11002, and the IP phone connect to the PC. Okay. First of all, we go to the configuration at router 1. Okay, this one is router 1. For router 1, first of all, we must we configure the DHCP full for both VLAN voice and VLAN data. Okay, this one is the VLAN for DHCP full. Next, we configure the sub interface IP for IP address at this router 1. Okay, this one is the sub interface for F00, F F01, and S000 and S001. This one is the IP address 10.200.40.2.255.255.255.0. Okay, this one. After we finish this configuration, we go to the configure the telephony service at this router. Register the IP, your phone, and the extension number at here. We finish at this router, we go to the switch. Okay, at switch, we configure VLAN access and mode trunk. Just a minute. At switch, we configure the VLAN access and the mode trunk. This is VLAN service for F001. F001 F001 F01 is at here. We connect to the R1, and F02 is VLAN 15 voice is connect to the first IP phone. This one is VLAN 03 is connect have two VLAN 10 and VLAN 15. It's because have two IP phone and PC. And VLAN 10 is for is for the PC for data, and VLAN 50 is for the IP phone and connect to the PC. This one is for the configuration for the switch. Okay, after we finish at this switch, we go to the IP phone. Yeah, IP phone 1 on IP phone 2. We try to call from here to here. We call 1101. The phone is ringing and this connected. Okay, settle for the router 1. Next, I would like to pass to my partner. Thank you.
Okay, let's proceed to router 2. Okay, my name is Ashraf Hanif. I will proceed about the explanation about router 2. Okay, for the physical connection at router 2, we can see that the S001 from the router 2 connected to S001 at the router 3, and then S000 at router 2 we connected to the S000 at the router 1. Okay. For the port F00 we connected to the switch F01 at the switch 2. Okay. For the then let's proceed to the configure DHCP pool for both VLAN at router. Okay. Firstly, we need to do a show run. Okay. From the show run, it will show the DHCP pool data, which is the network for the DHCP pool data. Network is 170.100.20.0. The .20 is for the VLAN for the data, which is represent VLAN 20 for the data, and then the subnet mask is 255.255.255.0. Okay, then the DHCP pool voice for voice is 170.100.60.0. 60 is represent for the voice, the VLAN for the voice, and then the subnet mask is /24, which is 255.255.255.0. Okay. Then after that finish configuration of DHCP pool, we need to proceed to the configure the sub interface IP address at the router 2. Okay. For the router 2, we assign the FA 0.0.20, which is represent for the data, and then 0.60 and for the voice. Okay. For the 0.20 is 170.100.20.1. For the VLAN 60, 170.100.60.1. Okay, let's proceed to the configure VLAN access at mode trunk, which is at the switch. Firstly, we need to do a show run as well. Okay, we can see here that interface FA01 is as mode trunk that is connected to the router, and then FA02, which is the VLAN 60 for the voice. You can see here, this is VLAN 60 FA002, and then this is FA03. Okay. After that, we configure the telephony service at router. Okay. For the telephony service, we need to assign the register. We need to register ePhone and register station phone number. Okay, we can see here. ePhone 1, the number station is 2201, and then ePhone 2 2202. And then we need to do a router protocol, which is EIGRP. The router EIGRP, we assign the number 78, which is the network address is 10.100.20.0. 10.20.0 is the network from the router 2 go to the router 3. And then 10.200.10.0 is at the router go to the switch, and then 10.200.20.0 is at the router that connected to the R1. Okay. After that, we proceed to the dial peer. Dial peer for if more than one router that connected. So this is the configuration, which is voice 10 volt. Okay, the session target for the voice 30 and 40. Okay, let's proceed the testing of the VoIP phone. So we need to open the two different VoIP phone on the same router. Okay, so okay, I will call from here 2201. That's the phone work. Okay, that's all from me. Thank you. I will pass to my partner Asyraf.
Asif.
Okay, now moving on to the router 3, which is by me, Hasif bin Roshidi. Today now for the physical connection, as we can see, there are two IP phone which is registered with 3301 and 3302, and also to get connected with PC3 to a switch. Now in this one, as we run the command shall run first. Okay, as we can see, there are two type of VLAN being assigned here, which is data and voice. For data, 170.100 and .30. Meanwhile, for voice, 170.100 and .70. Both also need to be assigned with default router, which is 30.01 and 70.01. But the option 150 command need only to be signed at full voice. And after that, of course, we must assign the sub interface. As we can see, the FA00 is assigned with 10.100 and .30.20. Meanwhile, the VLAN also need to be assigned with their own sub interface, which is 0.30 with 7.100 and .100 and .30 and .1. And meanwhile, for voice pool is 0.70 with 170.100 and .70.1. Okay, now move on. Wait a minute. These are also serial 00 and serial 01, which is assigned with 30.1 and 20.2. This is important so that you can connect with other router. Now let's move on to the switch. We do the command shall run first. Okay, now let's see at the port FA01, which it is assigned with switch port mode trunk, which is very important so that the call or data that we gonna get from the host gonna be available at the router. Now for the FA02, it is assigned with 30, which is the 30 is VLAN for data, and data is assigned at PC. Now for 03 and 04 is assigned with VLAN 70 because this VLAN is for voice mainly, these two IP phone. Okay, now let's back to the switch one. The routing protocol that is necessary to be configured is the EIGRP, as has been told in the lab sheet. we decide to use the 78 code with 3 network together with subnet mask. These 3 network is representing the way is to connect to the other router. The 30.0 which is the FA00 and the other two is the serial to 20.0 here and 30.0 at here. And now after that, we assign the telephony service. This is important so that call can be made between these two and the other phone at the other router. ePhone DN1 with 33.01 for iPhone IP phone 3.1 and ePhone DN2 for iPhone 3.2. Okay, last but not least is the dial peer. This is the most important one. Dial peer is purpose is to enable phone at this router to be able to call at phone IP phone at other router. So in order to be able to do that, we must assign a dial peer voice 10, which mean every other voice VLAN at other router must be assigned at router 3 so that it can connect between each other. Okay, now finish about in router 3. Let's I pass next for the router 4 for my partner Muhammad Asraf bin Toni.
Okay, thank you Asif for the explanation on R3.
You're welcome.
Okay, now we will move to the R4, which is the last part of this network diagram. So as we can see, the network diagram for R4, it has the two type of connection. The first one is the trunking connection that are FA00, which connected from the router to the switch. And we have two serial connection, which we use S000 and S001 to connect to the another router R3 and R1. So without wasting our time, I would like to show about the overall command in R4. Okay, for R4, we use VLAN 40 for the data and VLAN 80 for voice. And okay, the reason why we set up the default router IP address because we don't want the other end host that will use the IP address will overlapping with the default router. It will cause the network cannot be communicate successful. And then okay, and then this is the we configure the sub interface. Okay, sub interface. The reason why we use the command encapsulation .1q is because this is the default configuration that allow us to set up the IP address in the sub interface area. So if we not include the encapsulation protocol in this command, it will prevent us to include the IP address, and then the result is the IP address that we want to put will be located in the regular port, which is FA00. Okay, same goes to the port .80, and then okay, if we can look in this section, we have the IP address for the interface series 000 and 001. Okay, this IP address we will configure to match up in the EIGRP protocol later, and then okay, and then we will continue in the switch switch overall command. Okay, as we can see is we spend the FA01 special for the Mutrang. Yeah, because the different from the different of FA01 with other port is FA01 is technically is a default port for the trunk, where the others is only the default port to the end host. The difference is for the trunk, we use the command is switch port mode trunk, and the port that connected to the end host, we use the switch port mode access. Okay, as we can see here, for interface FA cos 01 will be located in here. The connection from R4 to the switch, we use the mode trunk, and FA02 is the connection of from the switch to the IP phone, which is we conclude it with the switch port voice VLAN 80, and the other port which are the FA03 and FA04 using the same protocol, because the end host only provide data, not voice. So the VLAN type that we use is the VLAN 40. Okay, finish the configuration at the switch. Now we turn back into router. We will turn back into the router. Okay, the router, after we finish configure the port type in the switch, we will start to configure the port for the telephone. Okay, for the telephone, we only use one IP phone. So the basic configuration for phone is only the telephony service, and maxi phone mean how many number of IP phone that we want to use, and max DN is stand for the maximum dial number. So for this case, we use only one. We use only one IP phone. So we will set up the DN number is 4401. Okay, the specialties this design we then compare with others is this design only have one IP phone, so it cannot communicate in uh, in in its own network. So the so if we want to try the connection is successful or not, we need to call from the IP phone in R4 to the IP phone in any router in this network. Okay, for example, that I want to use here is I want to call from R4 to R2. Okay, so this is I want to call 2201. Okay, 2201. Okay, I will call here. Okay. The the connection is successful because we apply the EIGRP protocol in this network. So for the EIGRP protocol in this network is we have three default network address, which are 10.100.40.0, 10.200.30.0, and 10.200.40.0. So for 10.100.40.0 is the outer connection between the R4 and to the R1. The another two IP address 10.200 is the inner connection between the router and the switch. Okay, so the function of EIGRP is we can transmit the data connection across the region without a failure. Okay, that's all for the explanation of R4. So I will come forward to the conclusion. As the conclusion, I would like to highlight 5 main points for this purpose of the network design. Okay, the first one is the EIGRP is enable us to easy transition to IPv6 protocol with the multi-address family apart from the IPv4 IP address. So that's mean if we cannot use the IPv4 address, the other way to enable all is the connection is we also EIGRP also can be used by putting the IPv6 protocol. Okay, and another point is the EIGRP is more suitable to configure, more suitable to implement in the large scale of network, better than other protocol like OSPF protocol, IGP, and ACL protocol. So it's because EIGRP is more faster in conversion time. So in the other word, the rate of data transfer in a certain time is higher than the other protocol. So EIGRP is more likely a clear version that we can use, more better version that we can use to implement, to combine all the network into one. Okay, the number 4 point is EIGRP only change in a region of routing table, not the entire routing table. For example, if we like to change the routing table in the R4, as if we implemented the EIGRP in the network design, it only change in the R4, not the entire router that will change. So we can easily detect troubleshooting the failure if it cannot connect after that. And the last point is the EIGRP is more priceless than using another equipment for the transition method. So instead we using the another router or another multi-layer switch, the of course will use as more big capital. If we can implement the EIGRP protocol, it will surely can save our money, and this system is, I believe, is more reliable nowadays. Okay, so this is the end of our presentation. Thank you.
Okay, so that's all from us. Hope you enjoy this video. Please give a like and share. Thank you.
Assalamualaikum.
Waalaikumsalam.
Thank you to everyone.
Berapa minit tu?